All right, 3.7 talks about inverse functions. So inverse operations are operations that undo each other. For example, adding and subtracting undo each other. Multiplying and dividing undo each other. Squaring and square rooting undo each other. So inverse functions undo each other. So just a quick refresher, a function has one y for every x, and you can tell by a vertical line test. Vertical line test. A one-to-one function also has one x for every y, and you can tell that with a horizontal line test. In order to have an inverse, a function has to be one-to-one. So it has to go both ways with the one or the other. So if we want to find out if a function undoes another function, one thing we can do is pick a random number and plug it in for x. So let's say I pick 3. If I plug that into f, 8 times 3 is 24. 24 plus 5 is 29. If I plug that 29 into g, if it's actually an inverse, we'll end up with what we started. So 29 minus 5 is 24. 24 over 8 is 3. So because that's what we started with, the function undid the work and became the same number. We ended where we started, so they're inverses. Another way to check is to do Fogg and Goff, so do your compositions. And if they both work down to x, they're inverses. So for Fogg, we take g and plug it into x. So I'm going to write the function of g, where x is, and then simplify. So the cubed root of a cube of a cubed root cancels it out. 1 minus 1 is 0, so we're left with x. And then if we do it the other way, we take the g function, but instead of x, put x cubed minus 1. When you're adding and subtracting, you don't need the parentheses. -1 plus 1 is 0, and the cubed root of x cubed is x. So since those both get to x, these are inverse functions. Let's do another one of those, just to make sure. So if we're doing Fogg, I'm going to write x, but instead of the x, I'm going to put g. And now I simplify. So those 2's are going to cancel. -3 plus 3 is 0, so I get 0. Then if I do Goff, we take f and stick it in for g. So 3 minus 3 is 0. The 2's are going to cancel. And again, we get x. So those are inverses. So that's a couple different ways to check for an inverse. If you have a table of points, first you're going to check, is it a function? So we go through, all those x's are different. Yes, it's a function. Awesome. Then we look for one-to-one. So here we have two y's that are the same, but the x's are different. So this is not one-to-one, which means there's no inverse. So let's do the same thing over here. Check. All our x's are different, so it is a function. All the y's are different, so it is one-to-one. Now, to find the inverse, we're just switching the x and the y. Undoing themselves switches the points. So 3, 1 becomes 1, 3. 0, 2 becomes 2, 0. 2, 3 becomes 3, 2. 4, 0 becomes 0, 4. Now this is the inverse. We do the same thing when we're trying to find the inverse. First, we decide if it's one-to-one. Then we switch the x and y and solve. So this is 2x plus 5. So if we graphed that, it would be a line. A line is a function, and it's one-to-one. So yes, this one has an inverse. So we're going to start by taking it out of function notation. And so it says y equals. Then we're going to switch the x and the y. And now we solve so that it says y equals. So I'm going to add 5 to both sides. Then I'm going to divide everything by 2. And now it says y equals again. The way you write inverse is you put this little tick mark up here. So that says the inverse of x, or the inverse of f of x. And so I would just write it like that. Now let's look at g. G is a quadratic, so if I graphed it, it would be a u. It is a function, but it's not one-to-one, so there's no inverse. So let's look at h. A cubic function would look like that. So it is one-to-one. So we're going to say, yes, there's an inverse. So start by taking it out of function notation. Switch the x and y. And then solve. So we take the cube root of both sides. Add 2. So we get the cube root of x plus 2 equals y. And then we put it back in function notation. So the inverse, so that little tick mark, is the cube root of x plus 2. So that's how you do it algebraically. Now for graphing, what we're really doing is we're reflecting it over the x and y, or we're switching the xy values. So this point, negative 2, 0, becomes 0, negative 2 for the inverse. This point, negative 1, 1, becomes 1, negative 1 for the inverse. 2, 2 becomes 2, 2, which ends up being the same point. And then 5 root 7, and let's see, the square root of 7 is about 2.7. So we plot 5, 2.7, and then we flip them. So we get 2.75. And then if we connect those, 2, 2. Would help if I put things in the right place. So if I connect those, the first graph is this one. And then the second, the inverse, is that. So it's flipped over y equals x. All right, let's try a couple more, and then we'll talk about the domain and range. So this might look scary because it has a radical. It's really not. So we start by taking it out of interval notation. Switch the x and y. Square both sides to undo the radical. Subtract 5 to get y alone. Oops. And now we have our inverse. So x squared minus 5. Sometimes when it gets a little tricky, and it's not really tricky, it's just you have to think a little bit, is when you have a fraction. So we're still going to start it the same way. Now we're going to switch our x and y. Now we need to get rid of the fraction. So we're going to multiply both sides by the denominator, which is y minus 1. So we get x times y minus 1 equals 2y. Now we're going to distribute the x to get rid of the parentheses. And so now you're looking at this and you're like, there's so many letters. What do I do? Well, we need to get all of the y's on one side. So first I'm going to get this x over to the right. So I would get 2y plus x. Then I'm going to subtract 2y. So now I have both of the y's on the left. Since both terms have a y, I can factor that out. So xy divided by y is x, and negative 2y divided by y is negative 2. Now the y is alone again, so we can divide by x minus 2 to get the y completely by itself. And then to make this interval notation, we would do the inverse. So while it looks like it's scary, the hardest part is right here, just figuring out how do I rearrange it so I can factor out that y. And then the last part of this section is about the domain and range. If all you're doing to find the inverse is switching the x and y, then your domain and range are just going to switch. So if the original domain was -2 to infinity, then the new and the range was, say, 5 to infinity. For the inverse, those are just going to switch. The domain would be 5 to infinity, and the range would be -2 to infinity. You just switch them, just like you switch the letters. And that is the end of chapter 3. Let me know if you have questions.